Welcome to today's lecture on robust design and development. Robust design is a systematic approach to product development that ensure a product performs reliability under various operating conditions and variation in the environment, materials, and user behavior. So, in today's lecture, we just go through the what is robust design and development, how robust design and development ensure product performance and operating conditions is good or bad. So, first we go through our syllabus and tools and technical techniques for robust design and development, advanced product quality planning, design failure mode, effect analysis and value engineering, product life cycle management, and product data management. In this unit, robust design and development, product development, we just go through the tools and techniques, how design failure mode, effect analysis, how product life cycle management is works in the industry areas, case studies on tech team center application in product design and development, DFMEA, minimum three parts, process flow chart, part print analysis. So these all are last previous year questions asked by SPQ University. What a short note on APQP? What a write a short note on DFMEA? Discuss the element of PLMA in details. These are basics questions asked by SPQ in last previous years. List down the FMEA and explain any one of which example. Write a short note on PDM. Discuss design for robustness in detail. Write a short note on APQP. These are also repeated questions asked by SPQ. Write a short note on design of robustness. Write the short note on product data management. Discuss the element of PLME in details. Explain FMEA with example. Differentiate the analysis and value engineering. Write a short note on product lifecycle management. This is the last previous year questions asked in 2024 by SPQ University. Write a short note on advanced APQP. This is also a repeated question asked in all three previous year questions. What is the importance of PLM? This is also asked in previous year questions. And list industrial safety to be considered in product design. These all are the basic question, and we can go through once we go through this whole concept, we can write by our mind in our words also. So, introduction to robust design. Robust design is the process of designing products or systems that are less sensitive to variation in control factors like environmental, materials, and user behavior, thereby ensuring consistent performance. So, why robust design product important? Enhance product reliability and quality, reduce cost by minimizing defects and rework, increase customer satisfactions by delivering reliable product. Historical content. The concept was popularized by Janice, who introduced method of two important in product design. Key principles of robust design: enhance quality, enhance product reliability and quality, reduce costs, increase customer satisfaction. During the design of any during we know during a design of any products, customer satisfaction is more important. Customer get products that perform as expected, leading to higher trust and loyalty. In product design, loyalty and customer satisfaction is the main point to be noticed by the designer. These can be improvised by the robust design. Reduce cost, minimizing defects and rework lowers overall product expenses. By using robust design, we can minimize defects, rework lowers our production expenses. Historical contents. The concept of robust design was to introduce a statistical method to make product less sensitive to environment variation and overall quality. Key principles of robot design. So first we go to the tolerance design. Tolerance. What is tolerance? We all, as a mechanical engineer, we all know that what is tolerance. Tolerance. So how tolerance work in design? Setting the appropriate tolerance for manufacturing process is key. Tight tolerances can be costly, but too loose tolerances can compromise quality. Setting, we know, if we go to the if we try to do tight tolerances, there its quality must be good, but it affects the cost of the product, which cannot be good for customer in customer budgets. It can be out of the customer budget, but if or when we go through the when we try to lose tolerance, when we too low we get too loose tolerances can be compromised with quality customer quality. Did in which loose pyramid can produce manufacturing precision. Robust design finds the optimal balance. With the use of robust design, we get the क्या हो रहा है? Parameters design, adjusting controllable design factors to optimize product performance in the face of variations. Advanced product quality principle planning. So, how APQP works in a robust design? Advanced product quality planning is a structured framework used in the automotive manufacturing and other industries to ensure products are developed with a focus on quality, reliability, and customer satisfaction. APQP is a proactive approach that helps organizations plan and manage and improve their product development process. Here are the key components and steps included in APQP. So basically in APQP, we just focus on quality, what is how quality, reliability, and customer satisfaction. How to plan, how to manage, and improve their product development so process cycle. Quality planning. The foundation of APQP is quality planning. The basic concept of any development of any product is start from the quality planning. It involves defining customer requirement, regulatory standard, and internal quality object. This step is set the stage for the entire product development process. Product design and development. This phase involves the creation of product concept, detailed design, and prototype development. Key activities include concept development, design review, and prototype testing. Is placed on identifying address prototyping issue early in the design phase. Process design and development. In this step, the focus shifts from the product to the manufacturing process. Firstly, we focused on quality, then we focused on process development, design and development. Now, in this step, we focused on the manufacturing process. It involved designing the product process, including the selection of equipment, tools, and facilities, ensuring that the manufacturing process is capable of consistently producing high quality products is essential. Product and process validation. This phase is dedicated to validating both the product and manufacturing process. Product validation. Confirming that the product meets customer requirement and specifications through testing and inspections. Process validation. Ensure that the product process is capable of consistently producing products that meet quality standards. In process validation, we have to ensure that the product coming out from the manufacturing unit will be meeting their standards, quality standards, tolerances, and other parameters that mentioned in design parameters. Feedback, assessment, and corrective actions. Ongoing feedbacks and assessment are crucial in APQP. Just after the manufacturing of any product, there are the feedback process in which the feedbacks and assessment are feedbacks are given by the customer, which how is that product is quality satisfactions or cost satisfactions. Is any product is faulty or not? Is the company is providing the good product or not? Is all these are crucial part which is included in APQP by taking feedbacks from the customers, assessment by the company employee. Company employee have to give assessment about quality, are they are aware about the quality parameters or not, and corrective actions. After the correct assessment, the employee have to take action like corrective action. They have to provide details about the, if they did not know about the tolerance, how much tolerance they have to keep in the during the manufacturing, or how the quality, which quality parameters they have to maintain. They have to, in the APQP, the corrective actions they have to be taken on the employees, deviation or dispensaries from the plan are identified and addressed. Corrective actions are taken to ensure the product and process meet quality requirements. After the feedback and assessment, corrective actions are taken to ensure the product quality and quality requirements. Launch assessment and feedback. Once the product is launched into the full production, ongoing assessment and feedback continue to monitor quality and make improvement as necessary. After once in APQP, once the product is launched, we don't we did not stop the assessment feedback. This process is ongoing in a cycling way. In a, just we can say, after 6 hours, after 5, after one day, the company or the system get the feedback form to ensure the quality is maintained by the employee or the company, or during the manufacturing process, or any fault, to remove any fault or minimizing the ongoing quality factors. Here the phase description and key outputs. What are the effects after the applying or APQP in product design? What effects or what outputs we get? Plan and define program. Understand customer needs and expectations. Before going to the market, before going to designing of any product, we have to plan how, what is the customer needs. We have to go through the customer. We have to ask customers, not only one customer. We have to go through maximum customers, how what market needs, how we can make this market as required, how we make this market our as our expectations products. Voice of customer, feasibility study, product requirement. And before after going to the customer, we have to face to face, we know what actual customer requirement, feasibility study, product requirement, preliminary bill of materials, product design and development. Second point is develop product design that meets requirement. After the plan and define program define, then we know what actually customer needs, and according to that needs, we have to develop the product design that define customer requirement. Design verification, design review, prototype testing. After the designing of the product, we have to take the prototype testing. Design review, is the feasible for customer, is the product design is meeting the customer requirements. After that, the third process is process design and development. Create a robust manufacturing process flowchart, PFMEA, control plan, work instructions. Fourth point is product and process validations. Verify that the design and process meet all specifications. After all this, we did plan, we meet customer need, we have the we voice of customer product, we have the design of the product, we developed the robust manufacturing process, we all done. After that, we have to meet the process and meet all specifications, that all these parameters mentioned in our design are verified by customer. Product trial run, measurement, system analysis, process capability studies. feedback, assessment, and corrective actions. After all these, we have in last FAQ system, we have to take the feedback from the customer, assessment and corrective actions to improve quality, product reliability, product life cycle, and other factors that affect the customer satisfactions. Design failure mode effect analysis. DFMEA stands for Design Failure Mode and Effect Analysis. It is a systematic structural approach used to identify, analyze, and prevent potential failure in product design stage before production begins. It helps ensure that the final product meets customers' expectations and functionality reliably. So next is the objective of DFMEA to identify possible failure mode in product design. DFMEA help us to identify failure mode, to evaluate the effects, to prioritize these, to implement corrective actions to eliminate or reduce these risks. When DFMEA is used, so our main question is the when we use DFMEA during new product design and development. Firstly, we use DFMEA during the new product design. Existing design are modified. In DFMEA, we also can modify the existing design. New technology, materials, and component are introduced. These are the some points, terms, and descriptions. Failure mode, the way in which design could fail to meet its functions, crack, deformation. There are many more mode of failures, cracks, deformation, as we all are aware about that. Effects, the result of the failure, result noise. After the failure of any object, we meet with some type of it is effects. It may be frictions, it may be hazards, it may be noise, it may be it also affect on the quality of the material. It may affect the performance of the machine. Cause the reason why the failure might occurs. The next topic, next word is cause. Cause. Why this failure occurs? What parameters affected during this failure? Weak material, poor tolerances, control. What things can be controlled by us to avoid this failure? Designing existing design measure to prevent or detect the failure. Failure mode and effect definitions, risk assessment, risk mitigations and preventions. Scope the DFMEA, define function, identify failure mode, describe effect of failure, define current failure preventions method, define current failure detection method, rank failure risks. Team formations. Assemble a cross-function team that include design engineers, subject matter experts, quality engineers, and other relevant stakeholders. This team will be responsible for conducting the DFME. Who? So our first question is who the person who form the DFME. DFME is a team formation process in which we have all the persons in our team who are working on this product development and manufacturing. That all the members have the knowledge about quality. One person has the quality knowledge. One person has the market knowledge. Sales and marketing persons are also including in this team. Design engineer also collaborate with the product manufacturing unit. Product select the design. Choose the specific design or component that will be the focus of the DFMEA. This can be for a new product or modification to an existing one. Break down the design. Decompose the design into its individual components, subsystem, and functions. This involves creating a comprehensive list of all the elements that make up the design. Identify potential failure mode. For each component or subsystem, brainstorm and list all potential failure modes. A mode is a way in which a component or system can malfunctions or fail to perform its intended functions. Determine the effect of failure. For each identified failure mode, assesses and document the potential effect on the product performance, safety, functionality. Consider how failure can impact customers, the environment, and other stakeholders. Yeah. Assign severity rating. Assign a severity rating to each failure mode to prioritize their importance. Severity rating are typically numerical value that indicate the potential effect of the failure on the scale, where higher number present more server consistency. There is some effects criteria severity effect of their ranking. Determine the cause of failure, assign occurrence rating, determine the detection rating, calculate, calculate risk priority number, prioritize and develop action plans, implement and monitor actions. Product life cycle management and product data management. Recycling, disposal, manufacturing planning, usage, maintenance, recycling, disposal. Product lifecycle management (PLM) and product data management are two closely related concepts used in product development and manufacturing to manage and optimize various aspects of product throughout its life cycle. While they are distinct focuses, they often often work together to enhance efficiency and collaborations. Product life cycle management. PLM is a comprehensive approach that focuses on managing the entire life cycle of the product from initial concept and design through production, survival, and disposal. It involves coordinating people's processes, business system, and information to ensure that the product is developed, manufactured, and supported effectively. PDM is a subset of PLM that is especially focused on managing and controlling product-related data. It typically involves around CAD, computer-aided design data, and other technical documents. Key picture of PDM is included: data repository, version and revision control, access control, change tracing, tracking, integration with all